Hello and welcome to today's webinar. My name is Melissa and I will be your host for today. Today's webinar is the third in our mini-series on InterPro, and today we are joined by Gustavo Salazar, who's going to talk to us about accessing InterPro programmatically. And with that, I'm going to hand over to Gustavo to run us through the webinar.
Thanks. Okay, so hope everybody is all right and can hear me properly. I'm gonna be talking about accessing InterPro programmatically. The idea of today's seminar is to continue showing you the features that we are providing in InterPro. In the previous two, Define was helping us understanding what InterPro is and what kind of data we're dealing with InterPro. And then in the second webinar, she helped us showing all this information that is in our website. All the information in the website is also available programmatically, so you can get it through a script and use it as you like. So I'll be showing you how to deal with this information, how to access it, starting from a very brief introduction to a REST API, the basic concept. Then take our main endpoint, which is entry, where we have our InterPro entries and so on. Then later I'll show you how that strategy that we use in entry can be used in other places of our API, and then show you how to deal with long lists when the result of your query is very long. Then I'll proceed to go to how to combine endpoints when you got entries and proteins together and that sort of thing. And finally, specifically the programmatic access. I'll be using a couple of examples in Python, but the idea goes through other programming languages. You might have noticed that I haven't mentioned anything about InterPro scan here, and I'm glad to announce that Gift will be presenting another webinar in about a month on the 24th of June that will just focus on this part. So today we'll be mostly focusing the data that we have pre-calculated and we have ready to access. But if you have your own sequences and you want to process that either to a web server or actually installing InterPro scan locally and run it locally, then that other webinar will be of your interest, and my colleague Giv Nuka will be talking about it then. So starting about the REST API and the concept of REST in general, it's a very simple thing. I have tried to do it to simplify it even more. When you go to any website, let's say you go to Google, you usually go to, you have your client. What is your client? It's your web browser. And in Google, you put www.google.com. That's your URL. You send that, and then Google servers process that request and return something. In the case of the web, what Google returned is a HTML with images and so on to create the web page you're looking at. On most REST APIs, the response is going to be some sort of structured data. In most cases, it's JSON, but could be XML, could be anything that can be structured and get that information from. Basically, it's just a question and answer. The server just receives the question in the shape of a URL and respond, in this case, in the shape of a JSON. And that's basically what our API in InterPro follows, as simple as. So when we were talking about entries in InterPro, we were always talking about, we have a protein, and in that protein, there are matches. Define showed you a few examples of how those matches are in a single protein, but what we have done in InterPro is to pre-calculate the matches for the whole of UniProt. So right now it's about 174 million proteins that are there. So we have run InterPro scan for each of those proteins and have obtained all that information. That is the core of what we provide in our API. The basic idea is that now you don't have to process completely every protein because most of the proteins are already there. Except it's a new protein, then you go for an InterPro scan search and so on. Everything, well, as I mentioned before in our API, is based in REST. We have a URL, then we get a response. The root of our API is this. We are ebic.uk/interpro/API. If I go there, this is what I get as a response. As I mentioned, what I'm getting is a JSON format, and in that JSON format, I get some extra information. Particularly in the root, what we get is the list of endpoints that we're gonna use and some metadata of the databases that are part of our set. If I then want to go and explore those endpoints, the list that was in that root API, then these are the basic endpoints we provide. Entries are our main point of view. It's our type of data. It's InterPro entries or member databases entries are part of this. So that's our main endpoint. But we could also get information of other types of data that are linked to our data. So that's why we have endpoints of protein structure, taxonomy, proteomes, and sets. So that's the very basic of what an API is. So let's deep into the entry endpoint. So as any of our endpoints, you basically, if we are in the entry endpoint, the only thing I need to do is to that URL I had before, just put that extra b /entry, and then you can get extra information about that. When you do that, you go to that web page, what our API provides is an aggregation, a sort of summary of the data we have for this endpoint. In case of entries, the data what we're dealing is the data we get, like for instance here, for how many InterPro entries are we having. In this case, we are in 37,264. One extra thing to notice is as part of the headers of the response, we include what is the current version of our data set, which currently we are in version 79. The rest of other counters for superfamilies, for Gen3D, for Prince, or all the member databases, and have given us the information, and we aggregate and integrate into our entries. So that's what you get in /entry. Basically, you know, every time you put /entry, you're gonna get a summary of that endpoint of the entry, how many entries are per each database. Then we go a little bit further and we say, no, not just entry, I want entry /interpro. That means that I am filtering the information of entries and I'm just interested in InterPro entries. Also implies that what I'm getting is not a summary. What I'm getting is a list of these entries. Every time you see entry InterPro, you immediately will know that is information about entries that belong to the database InterPro, and it's gonna be a list of them. So if I go here, then I get this list of entries. You see the results is in the notation, JSON notation for array, and each of them are all the InterPro. So IPR 001 is Kringle, 003 is retinoid, etc., etc. So again, summarizing /entry InterPro, then you know there are two levels in there, and if there are two levels, you're gonna get a list that is being filtered by that second part of the URL, so by InterPro. So it's a list of InterPro entries. You could use any of the member databases instead of here. So you can do a /entry pfam or others, and then you will get the list of the respective database. And finally, about the entry endpoint, then we could go into the detail of specify a single entry. So I already said it's entries. I already said that it's from the source database InterPro, and I'm really interested in this particular entry in the 126. In that case, it's 3 levels, and then we can assume what we're gonna get is an object with detailed information of that particular entry. If I link in here, that's what we get, metadata of that entry, and then we get extra information that we didn't in the list view. The list will give you some of this, but not all the details. For instance, this goes into listing the Go terms associated with it, the literature that is associated with that entry, and so on. And that's basically the entry endpoint. That's what you can get out of the entry endpoint. You want to know a big summary, then you say /entry. You want to get a list of something, then you say /entry member database. If you want to know a particular entry, then you go with the whole thing. And that's what I refer when I mean about the URL structure. This same concept is used along the whole API. So every time that you see slash something, you know it's going to be one of our endpoints, as if nothing else is followed, then it implies that it's going to be the aggregation view, some sort of summary about that particular endpoint, as the example that we went before, /entry. If what you get is endpoint and a database, then it's also implying that it filters by that database, and the return of that is going to be a list. And if you include an accession, then it particularly select that database, that accession, sorry. So these are a couple of examples that I get from it. So not just using the entry endpoint, but other endpoints. So if I go to API protein, what I get is a summary of the amount of proteins we have. So UniProt is providing right now 176 million of proteins. Of those, 558,000 are reviewed, and the rest are unreviewed. We get a list of proteomes, also taken from UniProt. So the database is UniProt, and then we are using in our database 17,000 of those. In this one, now it's 2 levels. What we're gonna get is a list, and then what is a list of what? It's a list of structures from the database PDB. So if I go there, that's exactly what I get. The PDB is providing us 152, and we get that list of entities. Same for sets is another of our data. Is some of the member databases group their signatures in some of them they call it clans, some of them they call it sets. So basically, is a group of signatures, and that's what we have for InterPro called set. So we can see, for instance, the set of the CDD, and this CDD these are called clans. So CL001 and plat, and so on. You can go into details of a particular entity. You want to know something about humans, so it's in the taxonomy UniProt 9606, which is the taxonomy ID. You click on that one, and it's all the metadata related to humans. For instance, it's the lineage, so who is the parent of that taxon ID in the whole taxonomy and the whole legacy of it. Or go for a particular proteome, and the particular proteome that I'm using here is the COVID-2. I'm just getting information from it. One thing that you will find in this sort of summary for an entity is that we have also provided counters at this level. So you know that for this proteome, for instance, there are 139 entries in total, 61 of them coming from InterPro and signature 29 from PFAN, etc., etc. But also we know that this proteome is formed by 14 proteins, and then you get that sort of detailed information from there. And that's the URL structure. So now you know from the very beginning, we have 6 endpoints and each of them can be queried in that way. So now you pretty much can have access to most of our data. The one thing I haven't mentioned is what happened when that list of items is really long. So for instance, I go to this one, entry SFLD. We know it's a list of entries and we know it's being filtered by the member database SFLD. Besides the results that I was showing you earlier, in the top part of it, as another key of the root dictionary of the payload, we also have a count. We know that this result is gonna have, this query provides 303 entities. The problem is if I check here, I'm doing a search in the page and I look for metadata, that now I know all of them are there. What I get is 20 of them. So telling me there are 303, but I'm getting 20. We have that as our default in the API. We only will give 20 by default. We put a limitation because if, for instance, somebody gets and you say protein/uniprot means that it's gonna download 174 million proteins in one go. That is something that is gonna take really long for you as a user, but also the problem is then that makes our server busy. And if many people do that sort of request, not many people, but like a certain amount of people do that sort of request, our server is going to be very busy answering those and end up blocking the whole service for everybody. So the first level of protection in that sense is we only going to give you 20 by default. If you want more, then you can actually specify, oh, well, the page size that I want is 200. So I go there, that page. If I do my search again for metadata, then I'm gonna have here that, yes, I have 200 of those entities. Yeah, but this one is 303, and 200 is our absolute maximum for this sort of queries. We're not gonna provide more than 200 entities in a single answer. So what is the alternative for that? And that's the other part that in that header appears. We have a key there called next. So you could, if you go to that web page, see that the next page is exactly the same. There is another couple of things in the URL, but it's just to inform the API, okay, start from where I left in this page. So if I have this page was metadata have effectively 200 entities. I follow this link, that is the next link, and then what I have in metadata is 103, so I complete my 303 entries on this case. One thing to notice in there was that the very last page of those, in the next, you're gonna find a null, and that's when you know is the end of it. So you have 1,000 entities, then you next, and then you're gonna have in the fifth page, the next is gonna be null, and you know that's where you stop. And that's what you need to know for dealing with long lists in our API. Just you can set up the page size up to 200, and you can get the next page from the current response. So there I have shown you all these endpoints in an isolated way. You can query information about proteins and get a list or get metadata from one particular protein or get aggregation. You can do the same for the structure, for taxonomy, for any of those. The interesting part is actually to start mixing this. How do I get the proteins that have a match in InterPro? How do I get the structures of a given protein? and so on. And that's where this section comes along. Excuse me. So now, yes, I'm going to start mixing the endpoints. Well, I'm going to combine these things. The way of combining is like I'm going to call for now the three levels that we have been talking about. I'm going to call that an endpoint block. So doesn't matter if it's only coming with the endpoint / protein, or if it's the endpoint and the database / structure / PDB, or is the endpoint database accession entry InterPro IPR 00001. Doesn't matter. All of that is the block for a single endpoint. So basically, the only thing I need to do to be able to combine this in our API is just put endpoint blocks together, as many as you want, as long as you don't repeat an endpoint. So if you use in your URL entry once, you cannot use entry again. And then the first endpoint block that appears is going to behave in the way that I have explained so far, meaning it's from there that I can identify what is the response going to look like. I am getting a summary. Am I getting a list of entities, or am I getting detailed data about one particular entity? So that's what you get out of the first endpoint. Any subsequent endpoint blocks will work as filters. So if, for instance, I'm having protein UniProt, I know I'm going to get a list of proteins, then I can fill that list of proteins by a particular entry or by a structure or so on. So I can use the second part or any subsequent block to filter whatever I got in here. So let's get an example. /API /protein UniProt /entry. So now I detect, oh, entry is one of the endpoints that we have. So that means that from then onward is a second block. So for the first block, I get protein UniProt. It's a 2-level block, which imply what I'm gonna get is a list. It's a list of proteins of the database UniProt, basically all the proteins that we have in there. And now filter that by entry InterPro IPR 0000126. The kind of link that we are putting here is the obvious link. What will be the relationship between protein and entries is a match. So when you put this sort of filter, what you are implying is there are matches in between them. So this URL, what will give me is, again, it's a list, as I said, protein UniProt, but it's a list that has been filtered by entries with that accession. So only proteins who have matches with this entry are going to appear in this list. So if I, again, I search for data here, I'm going to have 20. I haven't put my page size, so the default is 20. So I'm getting 20 of those, 20 proteins. And for each of those, I'm also getting an extra filter entries, which help me to understand the link between this query. So in this case, I am asking for filtering by InterPro 126. So what I'm getting here, the extra information I can give you between the links of these two entities is the location. So if you want to know the location of the matches of each of these proteins, then you just need to go entry protein locations for each of them. And that was mixing endpoints. So I used that example, particularly proteins in an entry, and that's probably the most common one. But like, for instance, one of the most common requests we get at InterPro is people asking for, I want the proteins that have a certain match with something, but also the proteins belong to human, or the proteins, yeah, specifically that, like human or any other species. So then now you know, well, I have an endpoint that is taxonomy. I have an endpoint that is entries, and I have an endpoint that is protein. I can put all those together, write a URL, and then you get the answer of the question that you need. All the proteins have matches with that entry that have that belong to human. So you write that URL in that combination. All right, I hope everybody is following me up to there, and then I'm gonna start talking about a little bit of programming. I'm gonna do a very simple thing there, a very simple sort of scripts to try to grab this information out of our API. I'm gonna reduce this, copy and paste this test of code, and then I proceed to explain line by line. I'm using Python 3 here for the example, but the concept can be written in any programming language you are familiar with, as long as you can have an HTTP connection, get data, and that's it. So in here, there are a couple of intermediate steps that Python requires to do, but nothing, excuse me, nothing really complicated. So first of all, I'm importing the things I'm needing. I need something to be able to do HTTP requests. And because my requests are going to be on JSON format, then I need something to parse JSON. I'm going to use a URL. In this case, the URL I'm getting here is InterPro API, protein uniprot. So I'm getting proteins, entry InterPro IPR 026. So I'm getting the matches of that. Same example I've been using in the presentation so far. I got the URL. Now I need to get a request, and this is just the Pythonic way of doing it. You can summarize this in less lines, but in Python, you need to create an object that is your request, and later you need to actually open that URL. So in first one, you define the request, and in the next one, you open the URL. That got stored in our response. Then that response, we need to read it, and that's what we do here, response read. The data that comes there, it needs to be decoded, and that's why we do in that part, decode. And finally, we need to parse this into JSON, and that's why we were using the library. So payload, JSON loads, the decoded response, and now we have everything in a payload. That means that all the data that goes from the API is now in a data structure that is understandable by Python. Therefore, I can use just normal Python to go through the data from there. In this case, from that payload, I'm gonna get the results. And in that case, I'm just gonna take the metadata and the accession of it. Basically, I'm just printing a line from there. So I run that, and this is what I get in here, just printing lines of that page. I'm gonna, sorry, put this bit smaller here. So just let's have a look to that URL in here. Excuse me. I'm gonna have the URL. That's the URL we are using. And based on that JSON, that's why I'm getting, oh, well, the first thing I need to get from the payload are the results, because these are the main keys. So the first key that I'm accessing is results. And for each of those, because it's an array, I'm gonna go inside, and each of those are objects. So on each of those items, I'm gonna get inside the object and get the metadata. And for each of those metadata, then I'm gonna get the accession. I can change that and say what I want to print, what I want to get is the name. Sorry, run that, and then I get the names from it. And then you get the idea. Now you have the data in Python structure. Therefore, you could just manipulate the data and create and use it whatever way you need it. But again, then that was for one page, a single page. Therefore, the number of things I'm getting here are 20, because in one page, remember, we are only getting 20 entities. So now what I need is to actually do this for all the pages. And it's very simple. It's just a repetition. So basically it's a while loop in here. I'm just gonna copy that part. So I'm gonna do all these things in my while loop until the URL is none. Remember, our stop of the URL is null. I need to change that URL to make the page to change. And I'm gonna take that from the payload. Remember, in the payload, we have that key value called next. So now the next is the next URL, and that will be my next URL. So the next time this goes here, it goes there. And I'm putting a sleep here. I need to import that. So I'll add that in my import parts. So now I can do sleep. This, I'm asking you to, whenever you do these sort of things, this sort of automatic calls, be nice with our servers. Just put in a small sleep. It's not long, it's just 1 second in between all the queries. And that will, like that 1 second doesn't mean much for somebody downloading, but means a lot for a server that has thousands of people downloading at the same time. So if you put that 1 second, our servers will be able to cope with all these queries. And then if I run this, so I get 1 request, 2 requests, 3 requests, 4 requests, 5 requests. It keeps going like, oh, something is wrong. I'm getting just blocks of 20. So I'm gonna stop there. And we know that, well, we can get bigger blocks, so we don't do so many requests by just adding, page size of size 200. And then when we go there, it's 1 request, 2 requests, 3, 4, 5, something, and finish. This particular query had, I think, yes, 1,168. So we recover all those proteins. As you see, well, the example there was very basic. I was just getting the accession, but I mean, you could use it to get any of the information that is in there. One more thing I would like to talk about here, now that we're dealing with programmatic things, is besides the reply itself, we provide a status code. This is part of any HTTP transaction that you do. And you might always notice the infamous 404 when you go into a wrong part of a page. So besides the content of whatever you are asking for, the server also gives these responses, this status code. So they have a meaning around. The 200 is the most used one, but it's not so famous because 200 means okay. So if you got a 200, everything went all right. So you don't have to deal with that at all. The 200 is all good. But when you get a 404, that was not found, and that's the most famous one because that's when you actually get irritated because you're getting things that are not. We send 404 codes when something went wrong with your query, when something is, we try to analyze your query and things were working wrong. So leaks, for instance, if your URL is API about endpoint, and I try to get that, the response, the HTTP response that you get is a 404. But you also use other things. We use no content. For instance, here, this protein with accession A0, A000 actually doesn't have any structures. And you are asking here for the structures of that protein. So what we return here is a no content, saying your URL was correct. What you are asking is something we understand. But when we look in the database, there is nothing on it. So it's an empty response. There is no content on it. A 408 is a timeout, and I'm going to speak about timeout in the next slide because that's a couple of details in there. 410 means gone. As part of the curation process that we have in InterPro, our curators check if the validity of an InterPro, and there is a chance that one InterPro gets removed. For instance, it might happen that the member databases decided to remove their signatures, and therefore there is not evidence anymore to have this aggregated entry. So one example of those is the IPR 0038. You actually get a response, you get some detailed information about what it was before, but immediately you are getting a HTTP call saying it's gone. So this is not a existing, this is not a current entry. Then when you see the signatures of that one, you notice that, for instance, there are some that have been deleted, or that this one is not pointing anymore to this aggregated InterPro, but is pointing to another one. So our curators have taken the decision to move that, remove 38 and put this pfound to point in there. And that's how you get information about things that have been removed. And finally, the one that you don't want to see and we don't want to send you, but it might happen, is a 500. It's a server error, and it's something that we couldn't detect what went wrong. And it might happen. It might be when many people is requesting things out of a server, and the server is so busy, then the server ends up returning a 500 because it cannot deal with that anymore, that load of users, and so on. So yeah, I'm gonna speak a little bit of timeouts, and this is because we have a particular strategy when dealing with timeouts. Some of the queries that are an InterPro that somebody can put, remember you can mix different endpoints. Some of these queries are very expensive for our database. Some of these queries require to process so much data that is gonna take too long. Our strategy here is we try to process whatever request the user puts in. If it's taking longer than 60 seconds, longer than a minute, then we return a 408. We tell you, look, this is too long. But we also keep that running in the background. It's not that we're just saying it's too long and we don't try to solve it. We actually keep running that and try to get a response for it. So if you later send the same URL, you might get the response because it was happening in the background and eventually got the response. And if we have calculated the response, we put it in our cache. So the next time somebody asks for the same thing, the response is going to be really quick. But if you ask for that URL and you don't get that response, you will get a 408 immediately. So the first time you query something that took long, it took 60 seconds to give you a 408. But if you send again and what you're getting is a 408 instantly, what it means is we are still busy processing the very first request. So the recommendation is try again later. So, putting, still processing, try in a minute, try again in a minute, and eventually that will get response. So that's the little addition that I'm gonna put in our script. So this basically these 3 lines here. I'm gonna put it here in our script. I changed a bit. It's in this one. It's not called res. It's called response. So if the response of it is a 408, again sleep for a minute, just a little bit longer than a minute, and then continue. Continue will take you to the while. We are not processing the response, but at least you gave 1 minute to our server. Sorry, and then it starts again. The URL hasn't changed because remember we changed the URL at the bottom. So when you do discontinue the URL, it comes back here with the same URL. So it's requesting exactly the same thing that you got, and then back here. Oh, you got another 408. Same thing. Wait for a minute, and then in a minute you will query. And eventually that response won't be a 408, but hopefully a 200. And when you get that 200, then we keep processing the rest of it. So if I run this. In this case, I'm not getting any timeouts because, well, we have queried this before, and all of the responses are going to be really quick. But if we would have been getting some of this from live and something complicated, like, you know, I want this, but only for this taxonomy, you know, I just want the human one, or I also want structures of it, or something like that. That is a complicated query. Then it's gonna take a while, and there is a chance that then you get end up finding a 4 or 5 timeout in it, and this would be the way of dealing with that. All right. Let me just do this again. Sorry. There. I'm just not gonna use that again. Just wanted to mention that in our website we have a script generator. So we create some templates, basically following the same ideas, the same concepts that I have mentioned it right here. If you go to the InterPro website, in the results, your downloads, you're gonna find this form, and in this is following the same concepts that we were talking. You select your entry, your main endpoint, you select which filters are you gonna use, etc., etc., and then we provide you with templates on different programming languages, Python, Perl, and JavaScript, that do pretty much what I've been talking. Maybe these examples of the templates I'm giving you are a bit more complete than the example I did during the webinar, because they're dealing with other sort of status, and in this case, JavaScript, using generators and trying to be clever to save time, etc., etc. So use this, but use it as a template for whatever you want. It's not like this is your solution and that's it. It's just a template, and then adapted it to whatever need you need, whatever need you have on your system. And that basically covers all that I wanted to talk in this webinar. Remember, if you have you want to run a sequence and calculate all the matches and that you need InterPro scan, and Gift will be talking about it on the 24th of June. Would like to thank the people from my group, all the people from the creator side, the web developers, the production developers, and the group head, Finn. With that, thank you so much. And if you have any questions, just pop it up in the chat. Thanks a lot. These are some links of documentations, and this is the link of the slides that I'm using here.
Thank you, Gustavo. We do indeed have time for questions this afternoon. So if you do have a question, please write it into the chat box. While you are doing that, just a little note to say that the information about our upcoming webinars is on our website. The InterPro scan one is not on there just yet, but I'll be adding that to the website tomorrow, so keep an eye out for that. We'll also send out some tweets when that is open for registration. Okay, so let's have a little look at the chat box and see if there are any questions. Okay, so there's one question that's come in that is there a way to get the responses in JSON in a compressed format?
So, not directly as a request, but it's intrinsically in the HTTP operator. So we have in our server, when we send that payload, it is a JSON, and like, for instance, a website that is requesting this will get that in compressed format. We are not exposing a particular parameter to say, send me this as a JSON, but the communication between the parts is actually happening in a compressed format.
Okay, thank you. So a question that came in earlier during the webinar was in relation to the security. Sorry, let me start that question again. So there's a two-part question: is do query sequences get disclosed in any way? Are they secure on the server and in transit, HTTPS and say AES 256?
So yes, our server runs on an HTTPS, so it is a secure server. In case it's closed in any way. I'm not 100% sure what it means by the query sequence. I don't know, the kind of query I'm doing is, what we're doing the APIs or URLs. The URL, well, if it's an HTTPS protocol, it does get, well, it has to pass. It cannot be completely encrypted. It has to get into the different servers. So I'm not 100% what I mean with the query. The response is running on HTTPS, so it is secure.
Okay, thank you. I think that Gift also posted a response to that question, just to point out that the search queries are deleted after 7 days as well, and that no one apart from you can see those.
InterPro scans query. Okay, I got it. Yeah, okay.
Okay, so I'm just scrolling down through. There's been a couple more questions come in as we've been talking. So there's one here that is, could you explain the difference between reviewed and unreviewed proteins? This might be something that Tiffen covered in one of the earlier webinars.
Yes, but I mean, the most basic thing to say is we're taking our proteins out of UniProt, and UniProt is split in two parts. One that they call SwissProt and another part that is called Tremble. SwissProt has been curated, manually curated, and that's why SwissProt has like 500,000 proteins instead of the 170 million that Tremble has, which are automatically processed. And that's what we call about review and review. So anything that is talking about review comes from SwissProt, anything that is unreviewed comes from Tremble.
Okay, thank you for that clarification. So the next question that I have on the list is there a way to get all the sequences matching a certain protein family or the alignments?
Sequences. Yes, we provide sequences on the API. When you query one protein, so let's go for, okay, this one. Is it too small, this screen? Sorry.
It's okay for me.
Great, okay. So if I get protein UniProt, that protein, in that protein, I'm getting the sequence as one of the things. So if I do a then I want the matches of it. So what I need to do is entry InterPro, because it's a list of entries of InterPro on that protein. And then we got the sequence from the previous query, and then we got the matches from this query. And the matches are here. So it starts in this place. Alignments, as in PFAM alignments, we are not providing that yet, but it's some feature that we are currently working on. So if you want the alignment coming from the member database, that, yeah, just wait a couple of months or weeks and we will give you that.
Okay, so there's another question that's just come in again. Is it possible to use InterPro scan tool using the REST API? And if so, how do you pass the sequence via the URL?
So it is possible to use the InterPro scan via an API, but not this API. There is another API that is part of the EBI web services that we can, you can send that. It is, the sequence is not sent on the URL, but that is a topic for the next webinar that Gift will be explaining in a few weeks.
Thank you. We'll look out for Gift's webinar to find out more about that one. Are there any more questions this afternoon? Just give it a moment or two to see if there's any last minute questions coming in.
I see people asking for R scripts. We are not providing R scripts at the moment. We provide Python, Perl, and JavaScript, basically because there are not R developers in our team to create the template. But if somebody wants to create a similar template for it and send it to us, we can easily include that in the future.
Thank you. I'd missed that one as I scrolled down. Okay, so it looks like there's no more questions this afternoon, in which case we will wrap up the webinar for today. Thank you very much, Gustavo, for the excellent webinar. Thank you everybody for joining us as well. And one last reminder, please do remember to fill in the feedback form that you will see in your screen shortly and let us know what you thought about the webinar. Hope to see you again soon and enjoy the rest of your day.
Thanks everybody. Bye-bye.